This is AP Calculus ABA, Unit 4, Lesson 7, using differentiation rules. We're to a fun part of the lesson, or the unit. So far we've been finding derivatives using the definition of derivatives, the limit definitions. Either the traditional differential or the dual two-sided differential or the alternate definition, but always a limit. That's long and tedious, and most mathematicians don't like long and tedious. So let's get to the shortcuts. First shortcut, okay? First shortcut is known as the power rule. So if I want to take the derivative of x to some power n, I take the power down in front and decrease it by 1. So the derivative of x to the n is nx to the n minus 1. Let me give you a couple of examples here. Okay? The derivative with respect to x of x squared is 2x to the 1. The derivative with respect to x of x cubed is 3x squared. The derivative with respect to x of x to the 8th is 8x to the 7th. Notice what's happening. The exponent comes down in front, and the exponent gets decreased by 1. The derivative with respect to x of 5x to the 3rd is 5 times 3, or 15x to the 2nd. Okay? And this applies to all powers. So what if we take the derivative of the square root of x? Well, we recognize that the square root of x is a fractional exponent. This is x to the 1/2. Bring the 1/2 down in front. Decrease the 1/2 by 1. 1/2 minus 1 is negative 1/2. Or, knowing the definition of negative exponents, this is 1 over 2 square root x. Negative 1/2 puts the x on the bottom, and the half makes it a root. Okay? All right, so that's really it with the power rule for derivatives. And we can break that up over addition, and polynomial functions. So we can do things like this. We can take the derivative with respect to x, 4x squared plus 5x minus 6. Bring the 2 down in front. 4 times 2 is 8, x to the 1. 5, think of that as x to the 1. 1 times 5 is 5. X to the 0 just drops the x off. And think of this as x to the 0, right? And 0 times negative 6 is 0, so the constant just drops off. So the derivative of 4x squared plus 5x minus 6 is 8x plus 5. Okay? There's a couple other rules that can be a little bit trickier to learn. One is called the product rule. Let's get there here. And let me express the product rule this way. If I want to find the derivative with respect to x of u and v, u times v, u is a function of x, v is a function of x, u times v. Take the derivative of the first, multiply by the second, plus the first times the derivative of the second. Let me demonstrate. If I have the derivative with respect to x of x cubed times 4x squared. Now I'm going to use the product rule, but there's no, well actually, yeah, let's do it this way. Let's do it as the product of two polynomials. X squared plus 3x minus 4 times x squared minus 5. Okay? I'm going to take the derivative of the first. This is my u. This is my v. So derivative of the first, 2x plus 3, times the second, x squared minus 5, plus the first, x squared plus 3x minus 4, times the derivative of the second, 2x. Okay? So that's the product rule. Take the derivative of the first, multiply by the second. Take the first without the derivative, multiply by the derivative of the second. Okay? That's the product rule. The quotient rule looks like this. if I'm taking the derivative of u divided by v, it's the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. Okay? So let me give you an example. The derivative with respect to x of x squared minus 5 over 2x plus 3. I take the derivative of the top, 2x, times the bottom, 2x plus 3, minus the top, x squared minus 5, times the derivative of the bottom, 2, all over the bottom squared. Okay? All over the bottom squared. So those are the formulas you need to remember: the power rule, the product rule, and the quotient rule. And we're going to use those to find derivatives much more quickly than we would have otherwise.